Welcome to the night before news for chemistry paper 1. Again, it's very important that when you get your science paper, you make sure it's the correct tier and subject for you. So if you are in set 2, 3 or 4, you want Combined Science Trilogy Foundation tier. If you are in set 1, you want Combined Science Trilogy higher tier. And if you are triple science, in this exam you'll be looking for the chemistry GCSE higher tier only. On all the papers there are a range of questions, from multiple choice tick box answers to fill in the blanks where blanks have been left in sentences for you to fill in, to short answer questions worth 2 to 3 marks, long answer questions which will either be 4 to 6 marks. Then you've got data and graph interpretation, and in one or more of your papers you will be asked to plot a graph. You'll also be asked to carry out calculations that are specific to that exam paper, and then you'll also be asked to carry out a percentage of maths on that exam paper. Again, they will ask you short answer questions in chemistry paper 1, and these will be aimed at testing your knowledge and being able to recall basic information such as atomic structure, the number of electrons in the outer energy level, types of bonding, so ionic and covalent bonding, whereas the long answer questions are more likely to focus around practical methods, so bullet pointing an effective method for obtaining a metal salt from an acid and a metal compound. Remember in that instance that it's really important you look at the acid, so if you had copper oxide and sulfuric acid you'd end up with the salt copper sulfate, whereas if you had hydrochloric acid and copper oxide you'd end up with the salt copper chloride, okay, the non-metal part coming from the name of the acid. They'll also ask you describing questions, explaining questions and evaluating questions again. In this instance, one of the things they like to do is ask you to describe patterns of reactivity for the group 1 metal, so what happens as you go down the group 1 metals, in which case you would just say the reactivity increases. If they were to ask you to explain why the reactivity increases, then you'd have to talk about atomic structure and the fact that as you go down the group 1 metals the atoms get larger, therefore they have more shells, and the distance between the nucleus and the outermost electron is greater at the bottom of the group with the bigger atoms, therefore they're more likely to let go of that electron, therefore they react more. And then finally they might ask you to evaluate the uses of, for example, 3 different metals, for maybe using one in electrical circuits, one as a metal for pipes in plumbing, and one for construction in bridges, and you would need to look at the data that they give you and then say which type of metal you would use based on their conductivity, their strength and their reactivity. Variables and understanding them again is a key aspect of chemistry paper 1. Same as all papers, your independent variable is the one that you or the person carrying out the experiment has chosen to change, and they've decided the values of those things. So in chemistry this could be temperature, pH, or it could be the concentration of a solution in moles per decimeters cubed. Again, dependent variables are named because they depend on the value of the independent variable. So they're the thing that in the experiment we don't know what the value is going to be, and we're measuring it because that's what we're interested in. So in chemistry, again, that could be the time it takes for a reaction to occur, the volume of gas that's produced. It could be a color change, it could be a temperature change, but it's whatever we are measuring as a result of changing our independent variable. And finally, control variables again are anything that could affect your dependent variables value, so they could also act as independent variables, and therefore we need to keep them the same. So this will be things like the mass of metal used, could again be the concentration of a solution, it could be the temperature, or it could be the time that we leave something for. Alright, so just bear in mind variables are important in this as well. Again, in chemistry paper 1, they will give you graphs and expect you to be able to read the scale. This scale is different this time, and we've got 1 milligram being equal to 5 small squares. So in order to work out the value of each individual square, we do the value of one division, which is 1 milligram, divided by the number of small squares that make it up, which is 5. So each small square would have a value of 0.2 milligrams. They also will ask you to calculate rates. Now, a rate is the production or use of something in a given amount of time. So here they could ask you, for example, to work out the rate of this reaction, and you would have to go along and see how much copper was produced in a given amount of time, and then you would do the amount of copper divided by the time taken, and that would give you milligrams per minute in this instance. The key calculations that are specific to this paper include the ones I've highlighted here. So calculating the number of protons or neutrons in an atom. If you look at the example for magnesium on the right hand side, it has a mass of 24, so that's the number of protons and neutrons in the nucleus, and it has an atomic number or proton number of 12. So we know that 12 out of those 24 particles in the nucleus are protons, therefore the remaining must be neutrons. So if you're asked to calculate the number of neutrons, you need to take the mass number and subtract the atomic number. So for this example, it would be 24 minus 12, and that would give us 12 neutrons for magnesium. They may also ask you to calculate relative formula mass. So this is when you take a chemical formula for a compound and you add together all the masses of the atoms that are in that compound. So the example I've given you is magnesium chloride, MgCl2. Well, we know that that's got 1 atom of magnesium and 2 atoms of chlorine. So it's going to become 24 plus 2 lots of 35. So the relative formula mass of magnesium chloride would be 95. Now the next section is for higher tier and triple students only. If you're sitting foundation, you don't need to know this, but for those of you who are sitting triple and higher, you need to know that 1 mole of any substance has a value of 6.02 times 10 to the 23. So if you've got, for example, 24 grams of magnesium, which is its mass, you would have 6.02 times 10 to the 23 atoms of magnesium. Now, how do we use that? Well, we can use this information to work out how many moles of a substance we've got if we know the mass of that substance and the relative formula mass. So moles is equal to the mass of something in the question divided by its relative formula mass. If we want to work out the volume of a gas, you need to work out how many moles of it you've got and then times one or the number of moles by 24, and that will give you the volume in decimeters cubed. Now concentration can be calculated in 2 ways. We can do it as mass per volume or moles per volume. So the top one is grams per decimeters cubed. So you take the mass of the substance you've got and divide it by the volume in decimeters cubed. And then the higher level would be moles per decimeter cubed. So you calculate the number of moles of something you've got and then divide that by the volume in decimeters cubed, and that will give you a concentration in moles per decimeters cubed. Finally, the maths components for chemistry paper 1. Again, they might ask you significant figures. So this is a different example. Here we've got 1.346 and we're being asked to do it to 2 significant figures. So 1 is significant and therefore 0.3, the 3 is our second significant figure. So we look to the right of that and we've got a 4. Well, that's lower than 5. So we round down. So our value is going to be 1.3 grams. They may also ask you to give results in standard form. So I've given you 2 examples here. We've got 0.0021 and that would be 2.1 times 10 to the minus 3. So if you imagine the decimal place is between the 2 and the 1, we've moved it to the left 3 spaces. Okay, so minus 3. And the next one is 1500000 would be 1.5 times 10 to the 6. And this time you imagine that the decimal place is between the 1 and the 5, and we've moved it to the right 6 places. Units are very important. So in chemistry paper 1, volumes are really key. So decimeters cubed and centimeters cubed, you need to be able to convert between them. So 1 decimeter cubed is actually 1,000 centimeters cubed. So to convert from centimeters cubed to decimeters cubed, you would divide by 1,000. And to convert from a decimeter cubed to a centimeter cubed, you would need to multiply by 1,000. Finally, calculating mean averages, you need to add together the values of all the repeats and divide them, the sum of those, by the number of repeats. So in this example, we've got 23, 25 and 22 are our 3 repeats. So we add those 3 values together, press equals in the calculator, and then divide that sum by 3, and that gives us an answer of 23.3 recurring. But however, we need to look at what the number of significant figures was for each repeat, and in this case it's 2 significant figures, so we have to round our mean to 2 significant figures. It must always be to the same number of significant figures as the values that were taken.